When installing parking lot gates, ensuring proper grounding and bonding is paramount for safety. The bonding conductor plays a vital role in providing a low-impedance path for fault currents, protecting equipment and personnel. In this scenario, the question concerns determining the correct size of the bonding conductor when the power source, a 120-volt single-phase panel, is located at a significant distance from the gates, specifically 450 feet to the first gate and 545 feet to the second gate, with each gate drawing a load of 9 amps. The initial calculation suggests using number 4 copper conductors for the main power feed. Given this information, the appropriate size of the bonding conductor is number 6 copper. This determination is based on established electrical codes and standards, primarily the National Electrical Code, or NEC. The NEC outlines the requirements for grounding and bonding to ensure electrical safety. Specifically, NEC Section 250.122 provides guidance on sizing equipment grounding conductors for grounding raceway and equipment. The size of the equipment grounding conductor is based on the size of the overcurrent protective device protecting the circuit. To determine the appropriate bonding conductor size, we need to refer to NEC Table 250.122, which correlates the size of the ungrounded conductors, in this case number 4 copper, to the minimum size of the equipment grounding conductors. Looking at NEC Table 250.122 for number 4 copper conductors, the corresponding minimum size of the equipment grounding conductor is number 6 copper. This number 6 copper conductor serves as the bonding conductor connecting the metallic parts of the gate and the electrical enclosure back to the main grounding electrode system at the service panel. This connection ensures that any fault current will have a low impedance path back to the source, facilitating the operation of the overcurrent protective device, such as a circuit breaker, to quickly de-energize the circuit and prevent electrical shock hazards. It is important to note that this is a simplified explanation, and actual installations may require additional considerations based on specific site conditions and local electrical codes. Firstly, always consult with a qualified electrician to ensure compliance with all applicable codes and regulations. Secondly, consider the potential for voltage drop over the long distances involved. While number 4 copper may be adequate for carrying the 9 amp load, a larger conductor size may be necessary to minimize voltage drop and ensure proper operation of the gate equipment. Thirdly, ensure that all grounding and bonding connections are made properly and are adequately protected from corrosion. Fourthly, use appropriate connectors and hardware that are listed for grounding and bonding purposes. Fifthly, consider the type of raceway used to protect the conductors. If metallic raceway is used, it must also be properly bonded to provide a continuous grounding path. Sixthly, be aware of any specific requirements related to parking lot gate installations, as these may vary depending on the jurisdiction. Seventhly, thoroughly inspect the entire installation after completion to verify that all grounding and bonding connections are secure and that the system is functioning as intended. Eighthly, document all aspects of the installation, including conductor sizes, grounding connections, and inspection results. Ninthly, consider the environmental conditions at the installation site. If the site is exposed to corrosive elements, such as salt spray, special precautions may be necessary to protect the grounding and bonding connections. Tenthly, perform regular maintenance on the grounding and bonding system to ensure its continued effectiveness. This may involve inspecting connections for corrosion, tightening loose connections, and testing the impedance of the grounding path. In summary, for a parking lot gate installation with a 120-volt single-phase panel located 450 feet and 545 feet from the gates, with each gate drawing 9 amps and utilizing number 4 copper conductors, the appropriate size of the bonding conductor is number 6 copper, as per NEC Table 250.122. Always consult with a qualified electrician and adhere to all applicable codes and regulations to ensure a safe and compliant installation. Additional factors such as voltage drop, environmental conditions, and specific site requirements should also be considered. Remember that electrical codes are updated periodically, so always refer to the latest version of the NEC and any applicable local amendments. The goal of grounding and bonding is to create a safe electrical system that protects people and property from electrical hazards. Proper grounding and bonding are essential for minimizing the risk of electrical shock, fire, and equipment damage. Therefore, it is crucial to understand and follow all applicable codes and standards when designing and installing electrical systems. Furthermore, it is important to consider the long-term reliability of the grounding and bonding system. Over time, connections can become loose or corroded, which can compromise the effectiveness of the system. Regular maintenance and inspection can help to identify and correct any problems before they become serious. In addition to the NEC, other relevant standards and guidelines may apply to parking lot gate installations. These may include standards related to lighting, access control, and security systems. It is important to be familiar with all applicable requirements to ensure a safe and compliant installation. In the context of parking lot gate installations, the equipment grounding conductor, in this case number 6 copper, is typically connected to the metal frame of the gate operator, the metal gate itself, and any associated metal enclosures or raceways. This creates a continuous grounding path that ensures that any fault current will be safely conducted back to the source. The grounding electrode system at the service panel provides the reference point for the grounding system. This system typically consists of one or more grounding electrodes, such as ground rods, buried ground wires, or metal water pipes that are in direct contact with the earth for at least 10 feet. The grounding electrode system is connected to the neutral conductor at the service panel, creating a low impedance path for fault currents to return to the source. This connection is essential for the proper operation of overcurrent protective devices. The size of the grounding electrode conductor, which connects the grounding electrode system to the service panel, is determined by NEC Table 250.66, which is based on the size of the service entrance conductors. It is important to ensure that the grounding electrode conductor is properly sized and installed to provide an effective grounding path. In addition to the equipment grounding conductor and the grounding electrode conductor, there may be other bonding conductors required in a parking lot gate installation. For example, if there are any separate metal structures or enclosures that are not directly connected to the gate operator or the electrical panel, they must be bonded together to create a common ground potential. This bonding can be achieved by using bonding jumpers, which are typically short lengths of copper wire that are connected between the metal structures or enclosures. The size of the bonding jumpers is determined by NEC section 250.102, which is based on the size of the largest circuit conductor supplying the equipment. It is important to ensure that all bonding jumpers are properly sized and installed to provide an effective bonding path. When installing grounding and bonding conductors, it is important to use appropriate connectors and hardware. The connectors and hardware must be listed for grounding and bonding purposes and must be compatible with the type of conductors being used. It is also important to ensure that the connections are made properly and are adequately protected from corrosion. In corrosive environments, it may be necessary to use special connectors and hardware that are designed to resist corrosion. Furthermore, it is important to protect grounding and bonding conductors from physical damage. The conductors should be installed in a manner that prevents them from being cut, abraded, or otherwise damaged. This may involve using conduit, raceway, or other protective measures. Regular inspections of the grounding and bonding system are essential for ensuring its continued effectiveness. The inspections should include visual checks of all connections, conductors, and hardware. Any signs of corrosion, damage, or loose connection should be addressed immediately. In addition to visual inspections, it may be necessary to perform electrical tests to verify the integrity of the grounding and bonding system. These tests can include ground resistance measurements, continuity tests, and impedance measurements. The results of these tests should be compared to the original design specifications to ensure that the system is functioning as intended. If any deficiencies are identified during the inspections or tests, they should be corrected promptly. This may involve replacing damaged conductors, tightening loose connections, or adding additional grounding electrodes. It is important to keep records of all inspections, tests, and repairs. These records can be used to track the performance of the grounding and bonding system over time and to identify any recurring problems. In summary, a properly designed, installed, and maintained grounding and bonding system is essential for ensuring the safety and reliability of electrical systems. By following the requirements of the NEC and other applicable standards, and by performing regular inspections and maintenance, it is possible to create a safe and effective electrical environment. Remember to always consult with a qualified electrician when working on electrical systems and to follow all applicable codes and regulations.